I'm a CNRS researcher and as well leading the laboratory of CHU de Montpellier, which is in Montpellier, south of France. And yes, we designed this assay called EasyCov, and I will show you what was the story around that and how we are now. So this laboratory, CHU de Montpellier, is a joint lab in between CNRS, academical research, and private company. Basically, it's an Alcon group, and two of the spin-offs of Alcon group are Alceliag and qu'il are resident here in our lab in Montpellier. Before the crisis, we were already involved in the diagnostic innovation and especially diagnostic assays in various diseases. When arrived the crisis, we had to go straight to the point, trying to reach the production of a new assay in few months. So we decided to go low-tech, and that's why we went into technology we had already in hands to develop an assay for detection of SARS-CoV-2 during the crisis. What was already existing was the nasopharyngeal RTQ PCR into laboratory, and it was reactive tensions, but as well queuing problems and so on. So we decided to shift for saliva for many reasons, mainly because it was an easy sampling method, but as well, at that time, a lot of healthcare workers were contaminated doing the nasopharyngeal swab. So we thought that it was a manner to avoid this contamination. And obviously behind this aspect, it was a practical aspect with the queuing and everybody focusing on a few centers for testing. And we thought that delocalizing was an alternative. But for doing so, we need to have a rapid test, simple, and obviously no lab facilities necessary for performing the test. So first aspect, the virus is probably produced, and it was demonstrated now, is produced in saliva glands. So there is a tropism for the virus in saliva glands, which make it very interesting for sampling. So that's why you can sample saliva without having to not drink or not eat during ages before the sampling. There were a lot of debate about the virus contents into the saliva because nasopharyngeal protocol doesn't work on saliva. And many people around the world used nasopharyngeal classical protocol for RNA extraction and purification. And this protocol doesn't work efficiently on saliva. You see here meta-analysis, which has been recently published early January, which show that with amplification systems, there are different, obviously, performances, but all the performances are reliable and useful for detection. So altogether, that shows that saliva is not a question at all now for sampling for SARS-CoV-2 detection. RT-LAMP is a technology we were having in hands for all the projects, and LAMPs is not, although it's now very popular because of the crisis, LAMP is a very old technology. It's very broadly used in on-field assay, especially for veterinary clinics. The advantage is that there is no temperature cycle. You usually run that as a constant temperature, mostly around 65 degrees, but it can vary lower or higher. And it's based on the polymer production. And so that's what you are going to detect. And thanks to that, there is various ways to detect the signal in LAMP systems. And so then it's a very versatile technology, easy to work and very cheap. In our case, as I was saying, we were during the crisis and we wanted to run fast, to go faster and more efficiently. We find that it was a good idea to collaborate. So obviously into our lab, we already had skill sets. So the teams were working heavily on the project for biotechnological aspect, designing a protocol, purification and extraction free for reducing the number of steps. And behind that, we wanted to have a connected assay in order to ease the work of the clinicians. And so we call a society called WOGO in order to design very quickly a very reliable and robust application, which in real time inform and transfer the information to the authorities. And obviously, you need to validate that in order to go to clinics. And so we worked with a hospital from Montpellier, University Hospital from Montpellier. And as well, to hit the system, we thought immediately that, okay, you can use a thermoblock that you classically have in a laboratory, but we wanted something, again, designed for clinics. So with a friend company from electronics, we designed a machine in a month or so, no more, which was a thermoblocks. And as well, there are batteries. So if you have no electricity suddenly, so then you can continue testing on field. And obviously the application from BOGO for direct detection of the color, because our test is a colorimétrique assay, and this direct detection induces a direct information from the national files. Our test is 40 minutes connected, and how it's processed by auto sampling by the people. 2 steps, one 80 degrees, 10 minutes, and then a few microliters of raw saliva treated with this temperature into a second tube for amplification and the direct colorimetric detection. The clinical validation was done on a real population on drive and blind and monitored. So in order to make sure that our comparison from nasopharyngeal swab and saliva sampling, which was simultaneous, was strong enough. What we observed is very interesting. And this is very important. When we only use RT-PCR from laboratory and comparing saliva and nasopharyngeal swab, then we see that we have some discrepancies. And especially here, you can see here saliva, which were positive and completely negative with no signal in nasopharyngeal swab RT-qPCR from the platform of the hospital. And you can see whatever the CT are, high CT or low CT, you have detection in saliva and not in nasopharyngeal swab. And so because of this, we saw that none of the technology are existing are perfect. And so we decide that RT-qPCR, it's a well-known strong technology, done on saliva and nasopharyngeal swab will be the reference. And here you can see our assay, rapid assay, 40 minutes straight with no purification. And you can see that each of the technology have separate and identification, which was not seen by other techno, but most of them obviously are detected by all the technology. But nasopharyngeal swab is from far the worst technology compared to saliva, RT-qPCR or RT-LAMP. And this is really something important. Our sensitivity is with EasyCov and saliva is 86%. For symptomatic and asymptomatic, the performance of our assay is as well very good. And to finish, just to say where we are in France. In France, basically, we were slower than everywhere in the world. The world around us were early adopters in airports, schools, industries. But at the end of the autumn, finally, our authorities released the assay in November, and it's reimbursed since January. So now the story is over in France. Efficient innovation for us in medical diagnostic in particular require good relationship between early research, clinic, and industry. And these 3 actors must be connected and knowing each other before to be efficient. And that's true for interdisciplinary, but that's true for intercultural aspect for industry and research. It was obviously a tremendous work from the teams, not only from CISDIAC teams, but as well all our support.